Hi everyone, welcome to this video on frequency distributions and histograms, a little introduction. You might want to watch the video on dot plots before you look at this one. If you remember, in the last video we were taking a look at some data of test scores, and here it is. And we plotted this data on a dot plot, and it gave us some things to analyze about our data. Another way of organizing our data is by putting it in what we call a frequency distribution, and we do that by making a table. And it's quite simple, really. It's just putting it into groups, or what we call classes. Sometimes it's called bins. There's different words for different books and so on. But what we're going to do here is create a frequency table for these test scores. So we have our test scores, and just to start out here with basically a two-column table, and over here is going to be the frequency. Okay. Now the first thing we want to do is create these classes, and classes are just ranges. So I think to keep it simple, let's take a look at, let's go by 10. So we're going to look at scores that, for example, lie between 40 and 49. How many students had scores between 40 and 49? That's what frequency means. All it means is the number of students that fall into that group or class. All right, and in this case, we only had one person who got a 49. All right. The next thing we want to do is create our next class. So the question is, what do we start with? Well, if someone has a 49, they're going to fall into this first group. So the next score above 49 is going to be 50. We want to make sure we capture all of our students. Now, it's very important that the size of each class is always the same. Otherwise, it just doesn't have as much meaning if your groups are different. So in this next class, the range will be from 50 to 59. And we can go through here and cross, and every time we see somebody between 50 and 59, we'll add them. So there's a 50, we'll cross it off. Here's a 55, there's another person. Just scanning, and I may miss some. There's another person. Here's 258, so I'll do two more tally marks. And any more 50s? Looks like we have a total of 5 people who were in the range of 50 to 59. All right. Next class is going to be 60 to 69. Right? And we could go through the process of going through our tallies and literally, doing them one at a time. But I'm going to save you the work and show, and I have already done this. So for example, there's 25 people in 60 through 69. In fact, what I did was I actually sorted, I sorted the data. As you can see here, this is the exact same test scores. I sorted the data and put it into groups of our class sizes. So here's my group of 5 students who got between 50 and 59 and so on. So the next group would be 70 to 79, and there's 10 of them. And then from 80 to 89, sorry, I apologize. I'm sorry, I'm getting these wrong now. Happens all the time. Okay, so let's erase these. Oops. I'm still learning this. And that's always how I make sure my students are paying attention, is that I make mistakes on purpose. Okay, so let's try again. 60 to 69 was, there were 16 students that fell in that category. Okay, and let's get my pen back. There were 25 students between 70 and 79. And between 80 and 89, there were 10 students. And between 90 and 99, there was 3 students. And then we can stop there because we have captured all of our data. Where there's nobody below a 40, there's nobody above a 99. So we can stop there. And in fact, if you sum up all of these numbers in the frequency, you should always end up with the total number of pieces of data that you have, in this case 60 students. And that's what you call a frequency table. Couple of things to note. This distance here from this lower limit to the next lower limit, so this 40 is a lower limit, 50 is the lower limit, 49 and 59 would be what you call the upper limit, 50 to 60, 60 to 70. These distances need to be the same. In other words, when you subtract them, you always get the same result. And so what we say in this problem, the class width is equal to 10. A couple of other terms too is what's the boundary? We can talk about class boundaries. Class boundaries. That means what number divides your lower class, the upper class boundary from the next lower class boundary. So for example, what would be that line between 49 and 50? Well, a simple way to do that is to just add the two numbers together and divide by 2. In other words, what you're finding is that midpoint. But most of you probably know what it is it's 49.5, 49 and a half. It's halfway between 49 and 50. And the reason I left a space there is because we often put the very first boundary, which would be our 39.5. It's kind of your starting point. And these become important when you start making your histogram. The next class boundary would be between 59 and 60, which puts 59.5, and so on. I'll let you list them all. So those are the important terms when thinking about a frequency distribution. We have distributed the data, organized it in equal size groups. Okay, what do we do with it now? Okay, so all a histogram really is the graphical representation of that frequency distribution. So I set this, started the graph here because it takes so long to do it otherwise, but it looks a little like the dot plot, and in some ways there are many similarities. So the x-axis, or the horizontal axis, will always be your data. So in this problem, it's our test scores, and our y-axis, or the vertical, will be the frequency, the number of students that fall into each of those categories. Okay, how do we label this? Well, notice I made some marks here. Well, now instead of having every single test score number, we've got those classes. And these are important marks right here because these are what we call those boundaries. So if you recall, the first class group, the first class, was from 40 to 49, right? And so, and our first boundary was that 39.5. And sometimes you see these in histograms and sometimes you don't. I wish they would put them on, but when you use Excel and things like that, they're often not there. But I think it's a great idea to always mark those class boundaries. So the second group, this one ends at 49, the next one starts at 50, goes to 59. And so you can see that each group is the same size, so it's symmetrical and it has its meaning, and it's visually representative of what we're doing of the data. 69.5, the next group was 70 to 79, and then this was 79.5, and then we have 80 to 89 with a class boundary of 89.5, and lastly 90 to 99. And technically this is 99.5. Okay. So you can probably guess what we're going to do next. We're going to fill in this histogram, and the way we do that is you want to think of it like bars or even bricks, and each person is instead of a dot is now an entire brick. So For example, we had, one person that was had a score between 40 and 49, and that was it. Just one person. This does not really looking like a brick, but it's this is really hard to draw on. But there's that one person. And I scaled this by 5s over here, but we can say that this is roughly 1 right here. Okay, from 50 to 59, we had 5 students. So we could do 5 individual little bricks, or we could think of stacking them all together on top of each other. And we're right up here. There's 5 of them all together in this range, this whole big group. And you can kind of think of it like here's, these 5 bricks just kind of layered right on top of each other. And again, my scale's not accurate, but so anyway, this is that bar, and this represents those 5 students that are in that group. All right, and again, if you've graph paper and a ruler, it's going to look even better. Our 60 to 69, that was 16 students. And notice we don't have exactly 16, it's about here. So I'm going to again, so we'll say 16 is about here, and again, we just want to think about those bricks. Not quite, nah. Oh goodness, I apologize. I'm still learning how to use this thing properly. It's not so easy. There we go. 70 to 79 took us all the way up to 25. So here's that class boundary, and here's the other class boundary. In fact, I'll grab myself a ruler right here and see if this works a little bit better. Oops. There we go. Probably should redo this video, but really, there's so much work. Here we go, you get the idea. And this next group is 80 to 89 was 10 people. So that's going to take us right to here. Okay, so let me draw those horizontal lines now too. So here's the bar for those people, and this was 70 to 79 is this big group right here. Okay, and then lastly, 90 to 95, there were only 3 people, which is about here below the line of 5, right around here. Okay, and there you go. There's your histogram. So for example, we have 16 people in this group right here. And so now you get this sort of visual representation of our data. It's sorted, it's organized in such a way. And it brings us back to some of those same questions we can ask ourselves from the dot plot. What sort of conclusions can we draw? How is the data spread out? I think from here, now we're seeing it a little bit more in a range. So, for example, we can see now looks like a really good chunk of students are right in here in this between 60 and 80. Yeah. In fact, we could actually figure out percentages. So I'm just going to write these above here. We have 1 student in this first bar. We had 5 students in this one, 16 here, 25 up here. We had 10 here, and only 3 here. So then we could start to ask ourselves some questions. For example, if getting a 80 is a B, these are our Bs, these students are our As, these are C's and D's, these are F's and F. All right, so we could ask ourselves, add a layer here. Just do this. What percent of students earned spell an A or B? Okay. Well, the way we would do that is we can see very clearly the way the lines are. We know that 10 people got B's, and we know that 3 people got A's. There were 60 students altogether that took the test, so we end up with 13 out of 60. And then feel free to use your calculator for that, and 13 divided by 60 is equal to 0.2166, repeating. All right, and that is approximately, if we just round to the ones place, 22% of students. So a histogram is just a nice way to visually be able to see some of the data, and then it's a little easier to answer certain questions about what's going on. And I might say, as the teacher, the administrator of this exam, I might say, well, that's an awfully low percentage of students have A or B. I don't really like that. I might try to adjust my exam so that it's not quite so difficult. Seems as if it might be a little bit of a difficult exam if I go back here and add some of these layers. Yeah, so we can see that not very many students actually earned a B or an A. We could figure out what percentage of our students, I'll let you try that one, what percentages of our students actually failed the exam, or in this case, if we include D's in that group, what percentage of our students don't get credit for this exam, if, assuming you have to have a C or better to get credit for the exam. So lots of different things you can look at. All right. And just to show you, you can also use technology um, to graph some of this data and put it in Excel. And you'll notice right here there is a frequency table that I just entered the data, and we'll talk about this more in class. But this is the actual frequency data that we created, and here's the histogram. It looks like what we did, just a lot neater. um, and then again, we can start asking ourselves those questions. Do we see maybe a slight skew to the left, or do we feel that this is more symmetrically um, uh, spread? Kind of hard to tell. And so you start asking yourself, well, how do I decide what sort of class widths to use? Well, that just comes with some time and practice, and it depends on what you're looking at. So let's take a look at a couple of others. I put these also in. Here's that same data that's spread just into two bins. And here we're ranging from 49 to 70 and 77 to 91. And actually, that didn't even use the data quite correctly. I'm still learning Excel, but as you can see, this really is not a great way to organize our data. It's too vague. What happened? Oops, let's put that one. What about this one? This one, the bins are a little bit smaller than our previous one. It's not marked here. When you use Excel, you have to go in and change a few things, and I didn't want to do with all these. But these bins are actually um, they're each a bin width of 5 instead of 10. So we end up with more bars, more classes. But again, we can sort of see that same kind of spread that we have there. What if we do even more bins and the class width gets even smaller? Well, then you start to say, well, what is this really telling me? There's just so many layers, so many bars now that it's hard to see, draw some overall some conclusions. And here's one where each class width is just 1.5, and you start asking yourself, well, is this really telling me that much? So same data, organized slightly differently. Each histogram is representative of that frequency table with varying class widths. So go ahead and practice some of your problems now, and look forward to seeing you in class.